This is the third part of the algorithm series, and in this video I'm going to talk about the insertion sort algorithm. And the insertion sort algorithm, it's a algorithm that we can use for sorting numbers, just like with bubble sort or selection sort. It looks maybe a little bit more complicated, but it's actually not that hard to understand. So let's start. The algorithm, the variable I gets set to 1, and we keep executing this whole algorithm while I is holding a lower value than length AR. So length AR is holding the value 5, I is 1, and that means that we will execute the algorithm. J is getting the value from I, so J will be 1. J is 1 now, and now we check if J or if the value of J is higher than 0, and yes it is. J is holding the value 1. And then we check if ARJ minus 1 is holding a higher value than ARJ, and ARJ minus 1 is holding the value 4, and ARJ is holding the value 3. And that means we will jump into this block and we will swap the values. So we will swap these values, the 4 and the 3. And the values are now swapped. Then we decrease J by 1. And then we can see already that J is 0, and that means we will not jump into this block because J is not higher than 0, and that means that we will jump to line 15. I gets increased by 1, and then we are here back, and we check again if I is holding a lower value than length of the array, and yes, that is true. 5 is higher than 2. So we keep executing. J is getting again the value of I. J is 2. And 2 is higher than 0. So J is holding the value of 2. And then we check again the values in our list. And ARJ minus 1 is holding the value of 4, while ARJ is holding the value of 5. So that means ARJ minus 1 is not higher than ARJ. So that means we will immediately jump to line 15, increase I by 1, and compare again, and I is lower than the length of our list. So that means we keep executing, and J is getting the value of I. J is 3, and here we can see already J is holding a higher value than 0, and that means we can go to the next comparison. And here we can see now ARJ minus 1 is holding a higher value than ARJ, and that means we will jump into this block and swap the numbers. So we will swap the 5 with the 1. Okay, so the numbers are now swapped. J gets decreased by 1. And again, we check if J is holding a higher value than 0. And yes, that's true. And then we will compare again the elements in the list, and ARJ minus 1 is holding the value 4, while ARJ is holding the value 1, and that means 4 is higher than 1. So that means that we will swap these values, 4 and 1. Okay, the values are sorted, are swapped, and J gets decreased by 1. And again, J is higher than 0, And then we can compare again the elements in the array. ARJ minus 1 is holding the value 3, ARJ is holding the value 1. That means we will jump into this block and we swap the 3 and the 1. So it's sorted. Now we decrease j by 1. And j is now not higher than 0, so that means we will jump to line 15 and we increase I by 1. And here we can see I is holding the value 4 and length is 5, so 5 is higher than 4, so that means we keep executing. I is getting the value of j, so j is holding the value of 4. And now we check again, if j is higher than 0, and yeah, it's higher, and that means we can again compare the elements on our list. And ARJ minus 1 is holding the value of 5, while ARJ is holding the value 2. That means we will jump into this block and swap the 5 with the 2. Okay, the values are swapped. J gets decreased by 1. And we check again. J is higher than 0. And then we compare the array or the list elements again. And ARJ minus 1 is 4. And ARJ is 2. That means we will swap these numbers, the 4 and the 2. Okay, the elements are swapped. And we will decrease j by 1. J is still higher than 0. So we can compare again the list elements. ARJ is 3, ARJ is 2, and ARJ minus 1 is then higher than ARJ. That means we will swap the numbers again. So the 3 and the 2. Now the numbers are sorted and the whole list is sorted. We decrease j by 1. And again, j is still holding a higher value than 0. And we compare again if ARJ minus 1 is higher than ARJ, but that is not the case. So we jump to line 15, increase I by 1, and now we can see I is 5 and length is 5, so that means I is, or length, the length of the list is not higher than the value of the variable I, and that means that we can, or that we will leave the algorithm to print the list. And here you can see the sorted list, and can also sort it like this so that it starts with the highest number. And here's a more Pythonic version with the one-line swap. And yeah, that's it for now.